The sun is really 93 million miles away. Why do short objects cast long, crisp shadows at sunset? Just pause on that for a second. Imagine holding a flashlight across your room and shining it on a coin. The shadow barely moves, barely stretches. But, bring that light closer and suddenly the shadow grows, sharp and alive. The closer the light, the longer the shadow. So here's the question. Why does our supposedly distant sun behave like a nearby light source when it rises and sets? If it's truly millions of miles away, shouldn't its light hit Earth almost perfectly parallel, making shadows stay relatively the same length all day? Yet at sunrise and sunset, those shadows react instantly, stretching and shifting with precision, as if the light were local. We're told this is just the angle of light. But is that enough to explain the immediacy? That intimate, almost personal movement of shadow to sun? Here's where history adds another twist. Ancient civilizations, from the Mayans to the Egyptians, described the sun not as a massive sphere in distant space, but as a smaller, closer light moving in a circle above us. Their calendars, temples, and sun tracking devices were built around that model and still managed to predict solstices, equinoxes, and seasons with uncanny accuracy. So what were they really observing? Were they wrong? Or simply seeing something we've forgotten how to see? Maybe this isn't about proving one model right and another wrong. Maybe it's about daring to trust what we actually observe. Because when you watch those shadows stretch at day's end, you're not just watching the sunset. You might be watching a clue about light, distance, and the very nature of the world beneath your feet. So next time the sun dips low and your shadow reaches across the ground, stop, look, and ask yourself, if the sun were truly 93 million miles away, would it still behave like it's right here with you? This video is for